In this video, I will go over the answers to the final exam review. We begin with problem 1. It states that a stenography school claims that its graduating students will average 80 words per minute in dictation. A sample of 18 graduates found that they average 78 words per minute in dictation, with a population standard deviation of 8 words per minute. At alpha 0.01, is the school's claim correct? So the claim is that the average is equal to 80. That's H naught. To write down H sub 1, it's the opposite. The mean is not equal to 80. Since we're given the population standard deviation, this is a z-test. We have two tails. Look up the critical values. We look for two tails on table F, 0.01, and go down to the very bottom. 2.58 is the critical value. So we have negative 2.58, positive 2.58. Now we calculate the test point. We could apply this formula. So we collect our information, plug it into the formula. 78 is the sample mean, 80 is the population mean, 8 is the population standard deviation, 18 is our sample size. We calculate negative 1.06. Let's verify that with the graphing calculator. We press STAT, go to Test. Option 1 is the z-test. Select Stats. Mu is 80. Sigma is 8. X bar is 78. N is 18. We want not equal to. Select Calculate. We have our test point, negative 1.06. That's going to fall short. It falls between the two critical values. So we do not reject H naught. Let's write out the summary. So the summary, remember the claim is H sub 0. We do not reject it, so we select this option. There is not enough evidence to reject the claim. Problem 2. It states a manufacturer of light bulbs claims that his light bulbs have a mean life of more than 1,150 hours with a population standard deviation of 80 hours. A random sample of 144 light bulbs yielded a mean of 1,169 hours. Find the p-value and use it to determine if there's evidence to doubt the manufacturer's claim. Use alpha equal to 0.05. So the claim is that the mean is greater than 1150. That's H sub 1. H naught is that the mean is equal to 1150. Once again, this is a z-test because we're given the population standard deviation. So we apply our formula to calculate the test point. Sample mean is 1169. The mean is 1150. Population standard deviation is 80 divided by the square root of sample size 144. Once again, we can use our calculator to verify that the result is 2.85. We press Stat, Test. Once again, select the z-test. Type in our information, 1150, 80, 1169, 144. We select greater than, and then calculate. and we get our value, 2.85. Below that is the p-value, 0.0022. So there's two ways of getting the p-value. If you have the graphing calculator, we just saw that it's 0.0022. But if you do not have that graphing calculator, then you have to look up the area for 2.85 in table E. So we have 2.85. That's 0.9978. That's the area to the left of that Z value. We want the tail area, so 1 minus that, 0.0022. We now compare the p-value to alpha, 0.05. Since the p-value is less than alpha, we reject H naught, and then using our summary chart, there's enough evidence to support the claim. Let's take a look at problem 3. It states a grocer claims that the average grocery bill at the store is $95. A sample of 20 customers' bills showed an average of $98 with a sample standard deviation of $7. At alpha 0.05, is there enough evidence to support the claim? Now, in this case, we're given the sample standard deviation. Thus, we're using a t-test. So our claim is that the mean is equal to 95. That's going to be H naught. The only option for H sub 1, the mean is not 95. We calculate our t-value using this formula. X bar is 98, the mean is 95, sample standard deviation is 7, and the sample size is 20. That's going to give us 1.92. To find the critical values, degrees of freedom is 20 minus 1, 19. Alpha is 0.05. So it's a two-tailed test. We look at our table, two tails, 0.05. We go down to 19, 2.093. Thus, we have two critical values, negative 2.093, positive 2.093. 1.92 falls in the non-critical region. Do not reject H naught. Once again, we summarize the claim is H naught. We do not reject it, so there is not enough evidence to reject the claim. So for problem 4, it states Foothill Hospital is comparing its performance against an industry benchmark that no more than 50% of normal births should result in a hospital stay exceeding 2 days. The sample data is that there are 31 births in a sample of 50 normal births that had a length of stay greater than 2 days. At alpha 0.05, let's test the claim that Foothill Hospital exceeds the industry benchmark. So the proportion, we're testing for proportions, that's greater than 50%, that's our claim, that's H sub 1. H naught is that P is equal to 50%. To calculate the test point, we need our sample proportion. That's X over N, so 31 over 50, 0.62. Q is 1 minus P, so P is 0.5, right? We convert it to a decimal, so Q is also 0.5. We then plug that information into our test point formula. 0.62 minus 0.5 divided by the square root of 0.5 times 0.5 over 50. The sample size is 50. That's going to get us 1.7. We can use our calculator to compute this value. You press STAT, go to test. We go to number 5, the one proportion z-test. P is 0.5. X is 31. n is 50, we want not equal to, and then calculate. And we can see that we get 1.697, so that's going to round to 1.7. This is a one-tailed test, alpha is 0.05, one-tail 0.05. Now remember, when we test for p, it's a z-test. So we're using the 1.65 as the critical value. 1.7 does fall in the critical region, so we reject H naught. We can use our summary chart. Remember, the claim is H sub 1. We rejected H naught, so we can state there is enough evidence to support the claim. Now, on problem 5, we're going to be comparing two means. We're given two sets of summary statistics. It states a sociologist wants to determine if the average life expectancy of people in Africa is less than the average life expectancy of people in Asia. Alpha's 0.01, test the claim. So we notice that we have our summary statistics for Africa and Asia. We're given the population standard deviations. This is a z-test. So our claim is that mu sub 1, the average lifespan of Africans, is less than mu sub 2, the average lifespan of Asians. That's our claim. That's H sub 1. H naught is mu sub 1 equal to mu sub 2. So our formula to calculate the test point is the difference in the sample mean. So we take 52.4 minus 65.1 minus, now remember, when we have a difference in the population mean, since we're testing for H naught, we consider them to be equal. This is going to become 0. Sigma 1, 7.4 squared, N1 is 45, plus 8.8 squared over 35. When we calculate, we get negative 6.86. Let's verify this with the calculator. We press STAT test, go to the number 3, the two sample z-test, type the data. We have 7.4, 8.8, 52.4, 45, 65.1, 35. Here we want less than, calculate. We get negative 6.86. Now this is a left-tailed test. To find the critical value, one tail 0.01, we go all the way down because it's a z-test to 2.33. Since it's on the left side, we make it negative 2.33. The test point falls in the critical region, so we reject H naught, and we state using our summary chart that there is enough evidence to support the claim. Number 6 is also a z-test comparing two means. It states a realtor hypothesizes that the average selling price of a home in the northwestern part of a certain city is significantly higher than the average selling price of a home in the southeastern part of the same city. If alpha is 0.05, test the hypothesis using the data. This is our summary data. The claim is that the average home price in the northwest side is greater than the average home price in the southeast side. That's our claim. That is H sub 1. H naught is that the two means are equal. So we take our information here and we plug it into the formula, right? Remember, since mu1 is equal to mu2, this difference becomes 0. When we calculate, we get 2.88. We'll verify that with the calculator. Press STAT, go to test. Number 3, 2 sample z-test. Type in the information, 62,783, 66,795, 995,620, 40, 952,725, 36. We want greater than, calculate. Our test point is rounds to 2.88. Now, since it's alpha's 0.05 and it's a one-tailed test, we can check to see that the critical value is 1.65 from our table. 2.88 does fall in the critical region, so we reject H naught and we say that there is enough evidence to support the claim. Number 7 states a wine merchant wants to determine if there's a difference in the average price of domestic wine and the average price of imported wine. If alpha is 0.05, test the claim. So we have domestic, imported summary statistics. We're given 2 sample standard deviations. This is a t-test. We're not given the population standard deviations. So we have a t-test. When it says difference, that means that the two means are not equal. That's our claim. That's H sub 1. H naught is that the means are equal. We use our formula to calculate the test point. Difference in the sample means 9.92 minus 7.12 minus the difference in the population means. Once again, since H naught is mu1 equal to mu2, that's 0. Divided by the square root of 3.54 squared over 15 plus 2.26 squared over 14. This calculates to 2.56. We'll verify that with the calculator. Press STAT, go to test, go to option 4. 2 samples z-test. We type in our information. We have 9.92, 3.54, 15, 7.12, 2.26, 14. We want not equal to. Pooled, always choose no. Calculate. T is 2.56. Now, to find the critical values, we calculate N1 minus 1, that's going to be 14. N2 minus 1, that's going to be 13. Pick the smaller of the two. So 13 is our degrees of freedom. We will look that up in our table. Two tails, 0.05, we go down to 13, 2.16. So we have a positive 2.16, negative 2.16. This is a two-tail test. 2.56 falls in the critical region. We reject H naught, and there is enough evidence to support the claim. Problem 8. It states the average price of 9 XYZ dishwashers was $8.45, and the average price of 7 ABC dishwashers was $815. The sample standard deviations were $19 and $49 respectively. At alpha 0.05, can one conclude that the average price of the XYZ dishwashers cost more? Once again, we're comparing two means. We're saying that the average of the XYZ cost is greater than that of the ABC cost. Mu1 is greater than mu2, that's our claim. That's H sub 1. H naught is that the two means are equal. This is a t-test because we're given sample standard deviations. So we apply this formula, 845 minus 815 minus 0 over the square root of 19 squared divided by 9 plus 49 squared divided by 7 to get 1.53. We will verify this using our calculator. So we press STAT test, 2-sample t-test, type in our information. X bar 1 is 845, S is 19, N is 9, X bar 2 is 815, S2 is 49, and N2 is 7. We want greater than, pooled, no, calculate, 1.53. Now to find the critical value, 7 minus 1 is 6, 9 minus 1 is 8, so degrees of freedom is 6. It's the smaller of the two. It's a one-tailed test, 0.05, and we go down to 6, 1.943. So 1.493, that's our critical value. 1.53 falls in the non-critical region, so we do not reject H naught, and we state there is not enough evidence to support the claim. Here we're going to work on number 9. It states, in a local city, citizens that belong to one of two particular political parties were asked to answer a survey as to whether they would like an increase in local taxes to fund the establishment of a new park in the city. Test a claim that the percentage of Democrats who favor the tax increase is more than the percentage of Republicans who favor it. Use alpha 0.01. So we have our data. Here we're comparing two proportions. So we have P1, which represents the proportion of Democrats who favor the tax increase. That's greater than P2, the proportion of Republicans who favor the increase. That's the claim. That's H sub 1. H naught is that the two P's are equal. So we have to calculate our first sample proportion. We divide 140 by 200 to get 0.7. Calculate the second sample proportion. Divide 90 by 150 to get 0.6. We also have to calculate P bar. So that's the sum of the X values. 140 over 90, which is 230, divided by the sum of the two sample sizes, 350. We divide, round to 3 places, 0.657. We also need Q bar. That's 1 minus P bar, so it's going to be 0.343. We take this information and plug it into the test point. So we have 0.7 minus 0.6 minus the difference in the population proportions is 0. P bar is 0.657 times Q bar 0.343 times, in parentheses, 1 over 200 plus 1 over 150. When we calculate that, we get 1.95. And then we can verify this using our calculator. It has a built-in function. Press stat, test, go to number 6, 2 proportion z-test. X1 is 140, N1 is 200, X2 is 90, N2 is 150. We want greater than, we calculate. Z is 1.95. And this is a one-tail test, so let's get the critical value. One tail, 0.01. Critical value is 2.33. When we test for proportions, it's a z-test. So we have 2.33. 1.95 falls short. Do not reject H naught. There is not enough evidence to support the claim. All right, let's take a look at number 10. It states a study is conducted to determine the relationship between a student's performance on an essay in an English class and his or her performance on one exam in a math class during fall 2019 at a local community college. The data are shown here. Test for correlation using alpha equal to 0.05. So the claim is that H naught is rho equal to 0. H sub 1 is rho not equal to 0. Now we're ready to determine the test point. We count the number of pairs. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pairs. Degrees of freedom is 10 minus 2, 8. Alpha's 0.05. So we go to table I. Alpha's 0.05 go down to 8.632. So we have negative 0.632, positive 0.632. Now we calculate R. We can use our calculator to do this. So we press Stat, Edit. We clear the old data. And we type in the new data. So I will type the X values into the first column and the Y values into the second column. Now we press Stat, we go to Calculate, select option 8. We need L1, so it's listing L2, so I just type second L1. We need L2 for the second column, and then we calculate. At the very bottom, we can see R. It's 0.969. This will fall in the critical region, so we reject H naught, and we say there is a linear relationship. Okay, so problem 11 is asking us to find the line of regression for our data. Since there is a linear relationship, the line of regression can be found by using the regression coefficients that was calculated when we computed R. So if we go back, we can see that A, that is the intercept. When we round this, it rounds to 4.779. The slope B is going to round to 0.941. So the line of regression is y prime equal to 0.941x plus 4.779. We can then use the value x equal to 75 to make a prediction, right? So we have a math score, 75, and we want to predict what score is earned for the English class. So when we plug 75 into this formula and we round to a whole number, we also get 75. So what it's saying is that if someone scores 75 on the math test, they will score 75 on their English lesson. Okay, number 12 says a study is performed to determine if the hours worked by student is correlated to the number of absences in classes by the student at school. Test a claim using alpha 0.05. So we have our data. Now we set up our claim. H naught is rho equal to 0. That's the claim. H sub 1 is rho not equal to 0. So Whenever we test for correlation, we always use these hypotheses. We have to find the critical value. We have 6 pairs, so 6 minus 2 is 4. Alpha is 0.05, we go down to 4, 0.811. So we have negative 0.811, positive 0.811. To calculate R, let's use the calculator. We press Stat Edit. We clear the old data. And we type in all the X values in the first column. Y values in the second column. Press Stat, go to Calculate, select 8. Make sure L1 and L2 are selected, and we calculate. R is 0.995, which falls in the critical region, so we say reject H0, there is a linear relationship. Now in the next problem, we need to find the line of regression. So it's y prime is b, b rounds to 0.135, x plus a, which rounds to 0.925. We're going to plug in the value 10, right? So 10 represents hours worked per week. When we calculate it, we round to a whole number, so we could expect someone to have 2 absences that semester. Right. Let's take a look at number 14. It says a clothing manufacturer wishes to estimate the average price of jeans in the LA region. She samples 50 pairs of jeans and finds the average price to be $55. The population standard deviation is $15. Use a confidence level of 95% to estimate the true mean price of a pair of jeans. So we're given the population standard deviation, thus we're using z-values when we calculate the confidence interval. So we take our information, n is 50, population standard deviation is 15, x bar is 55. Now to look up the z-value, we have to use 95%. 95% go all the way down to the z-value, 1.96. And then we calculate this to get that the mean price is somewhere between $50.84 and $59.16. We could also verify this with the calculator. We press Stat, go to Test, go to number 7, Z interval. Make sure we're on Stats. We type in our information, 15, 55, 50. Confidence level is 95%, so 0.95. Calculate. And we can see that the first value is 50.84, second value 59.16. Number 15 states, for a sample of 10 men subjected to a stress situation, the mean number of heartbeats per minute was 126 with a sample standard deviation of 4. Find the 90% confidence interval for the true mean. Now, since we're given the sample standard deviation, we're working with t-values. So we're applying this formula. To find the t-value, we need degrees of freedom. 10 minus 1 is 9. We go to table F to look up the value. 90% go down to 9, 1.833. So now we just plug in all the information. X bar is 126. T-value 1.833. Sample standard deviation is 4. Sample size is 10. We calculate to get the mean between 123.68 to 128 0.32. Let's verify with the calculator. We press STAT, go to test. We're going to go down to number 8, T interval. X bar is 126, S is 4, N is 10, confidence level is 0.9, calculate. We get 123.68, 123.32. Let's take a look at number 16. It states a survey of 120 freshmen shows that 18 did not wish to work after marriage. Find the 95% confidence interval of the true proportion of freshmen who do not wish to work after marriage. Right, so let's find our Z value, because when we find the confidence interval for P, we have to use the Z value, 95%, go all the way down 1.96. That's going to be the Z value. P hat is 18 divided by 120.15. Q hat, 1 minus P hat, so 1 minus 0.15, 0.85. And then we plug all our information, so P hat 0.15, Z 1.96, P hat 0.15, Q hat 0.85, N 120. Perform the computations to get P is between 0.086 and 0.214. We can verify this with our built-in function in the graphing calculator. Press STAT test. We go all the way down to 1 proportion Z interval. X is 18, N is 120, confidence level is 0.95. We calculate. Left endpoint 0.086, right endpoint 0.214. All right, for problem 17, it states the following. Assume that the heights of all horse jockeys are normally distributed. If the average height is 62 inches and the standard deviation is 3 inches, find the chance that a jockey will have a height greater than 66 inches. So we have a normal distribution. The mean is 62. We're looking for the height to be greater than 66. So we have to find this area. That represents the probability. We compute using our z-score formula. X is 66. The mean is 62 divided by standard deviation. We get 1.33. So we look up the z value, 1.33, in table E to get the left area. So when we look up the z value in our table, we always get the left area. So 1.33 is 0.9082. Right, so that's going to be this left area. We want the right area, so we take 1 minus 0.9082 to get 0.0918. Now, another way to do this is using the calculator. We want to use our z value, and we're going to the right. So second vars, number 2, our lower value is 1.33. The upper value is going to be the maximum value the calculator can handle, 10 to the 99. And then we select paste, hit enter to get 0.0918. Number 18 says that the average score on the GMAT is 450 with a standard deviation of 44. If a group of 34 individuals take the exam, what's the chance that the average of the sample will be between 470 and 490? Now, this type of problem is a central limit problem because we're given 35 individuals. That's a sample size. And we're looking for the mean to be between these two values. So it has a normal shape. The mean is 450, and we're looking for this area between 470 and 490. So we have to convert using our central limit z conversion formula. So first let's convert 470. 470 minus 450 over 44 divided by radical 35 is 2.69. And then we convert 490. 490 minus 450 over 44 divided by radical 35 is 5.38. Now we're going to look up both z values. So if we look up 5.38, it says any z value that's more than 3.49 has an area of 0.9999. Let's look up 2.69, 2.69, 0.9964, and then we subtract the two areas, larger minus smaller, to get the answer, 0.0035. Thanks for watching this video.